This week, we're focusing on regrouping with subtraction, which is a tricky concept to understand. So I want to show you a conceptual way you could show your child the reason why we do what we do with regrouping. Here is a 100 block to help. An example of a 10 and a group of 1, which we see represented here. Now, this is kind of confusing because this isn't a true representation of sizing here. So I have this as well to help out. Whenever you do it this way, you would only be drawing blocks for the top number. I believe in the KISS method, keep it simple, silly. So I absolutely would not have all these little lines. I would draw a square. I would draw a rectangle and a tiny square to represent the 1 if I were doing this on my own. So a little phrase that I use to help the students today to understand when they would need to regroup is I would say, more on the top, there's no need to stop. But if there's more on the floor, we have to go next door. This is a case where I could never subtract 9 from 3. I only have 3 ones right here. So I would need to regroup from my tens place. Now, if you look at my tens block right here, I have 10 ones within here. So I'm going to actually take this away. I didn't see that there, did you? And I'm going to make this into 10 ones. If you look here, I am not making my drawing fancy. If I were one that would benefit from drawing it on my paper, I would be doing quick little squares and done. Now, I can look at it. I noticed that I did have 2 sets of 10s, but I took one away and I regrouped, and I'm going to transform this into a 1. When I'm doing this quickly with my kiddos, I would just make this a 1 right here and transform that into 13. If your child wants to count, they absolutely can. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And that's how they get that. Now we can do 13 minus 9. If they're quick and they can do it in their head, awesome. If they need to physically cross it out on this paper, they can do that as well. 1, 2, 3, 4, 5, 6, 7, 8, 9. I am left with 4 represented. Now, again, if there's more on the top, no need to stop. But if there's more on the floor, we need to go next door. If you look right here, 6 is on the floor and it is larger, so I'm going to need to go to my hundreds place. Again, this is not a true representation of the relationship between the tens and the hundreds block. This would be correct right here. If you look at this and I had a set of 10, this would fit into here 10 times. So when I regroup, I'm going to transform this 100. It would be as if I'm literally physically breaking it apart and I'm making 10 tens. So I'm going to cross it out. I am not drawing it like that because I don't have time. So I'm going to just draw long rectangles like this until I have 10. I'm going to have 5 over here, 6, 7, 8, 9, 10. Let me make sure I did that correctly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. All right, when I did that, I changed it from having 8 tens to now having 7. So I'm going to cross this number out so I know not to look at it again. With my high flyers, I just make that a 1, usually in front, but 11 is still 11 regardless. If your child is a visual learner, like myself, they can physically count. We added 10 right here. I know that. And 10 plus 1 more is 11. So that's how we got it. They can go ahead and do 11 minus 6 if they can solve that in their head, or they can cross it out if they like to have the visual model. 1, 2, 3, 4, 5, 6. And we have 1, 2, 3, 4, 5 left. Now, again, if there's more on the top, no need to stop. But if there's more on the floor, we need to go next door. Well, there's no place next door, so I hope it works. 7 is larger, so we can do it that way. Again, they can just go ahead and solve 7 minus 4 if they would like, or they can actually cross it out. And we are left with 300ths. I hope this helps.